The ultimate goal of our project is to integrate antennas and sensors and readout electronics onto a contact lens.
Students and researchers at the University of Washington are creating contact lenses that can do a whole lot more than just help you see better.
So we're trying to convert contact lenses from relatively simple pieces of plastic or polymer to a functional system, something that may even someday resemble, in terms of complexity, your cellular phone.
The dot in the center here, this is an LED. The idea here is that we've got a metal antenna that's fabricated directly on the lens, and the antenna picks up radio frequency energy that's transmitted by an antenna elsewhere. And the chip harvests that energy and transforms it into voltage that can power the LED.
Dr. Babak Parvez believes one day these lenses will be able to transmit important medical information like glucose level readings directly to your doctor. The medical information gets transmitted out of a small radio that is placed inside the contact lens. Right now, the radio is always on and sends out the sensor readout, but in the future, the researchers plan to control the medical information readings more closely. The electrical engineer is also working with his team to create a display on the lens that will transmit information directly on the lens. Information will appear in front of the user as if it's suspended in air. This display can be turned on and off.
In your daily life, you deal with a lot of displays. You wake up in the morning, there's an alarm clock that shows you something that has a display. Then you may have a TV in your living room in the morning. The TV has a screen. During the day, you work on your computer, on your laptop, on your cell phone. You see many, many screens. They may be unnecessary, actually, if the screen is just your contact lens.
The goal sounds far-fetched, like something out of a science fiction novel, but laboratory tests have been promising so far.
We have actually developed contact lenses that now do things. We have sensors on contact lenses that can measure glucose. We have put light sources and radios and antennas on contact lenses and demonstrated you can actually turn on these very, very small pixels and display components.
Parvez credits a lot of the initial success with the lenses to other UW researchers who are participating in the project.
This requires electrical engineering and actually multiple different types of expertise in electrical engineering, very close collaboration with ophthalmologists, because the biology of the eye and what happens on that surface is of paramount importance to this project. This has been one of the privileges of being at the University of Washington, because the university is very, very nicely set up to enable these types of cross-disciplinary collaborations.
Engineering students like Andy Lingley know this could be a long haul, but the breakthroughs are exciting.
This is pretty huge, actually, because there's a lot of different things that need to come together to make sure that this device is going to work.
Parvez believes the world will be focusing on the UW one day for this revolutionary breakthrough.
I think this is a very promising field. We're definitely at the cutting edge of technology, and yes, it's happening in the state of Washington, at the University of Washington, in Seattle.